Okay, good evening, everybody. Thank you for joining us for our virtual subject evening. My name is Amy Smith and I'm the Marketing Manager at Lowestoft Sixth Form College. So during this session, we are going to be covering our courses in maths, further maths, biology, chemistry, physics, computer science and engineering. So we've got a lot to get through this evening and we've got all of our tutors here to talk you through each of the subjects. There's also a Q&A button, so you'll see that along the bottom of your screen. If you've got any questions as we go through the presentation, please feel free to pop them in there, and then when we get to the end, we'll answer them all at once live for you. So if anything springs to mind, then please do pop it in there and we will get to them at the end. So I'm now going to hand over to Ian McLean, who's going to give you a quick welcome and overview of his area that he looks after, and then take you through our first subjects as well. So over to you, Ian.
Thanks very much, Amy. Hi, everyone. Nice to see you all. So again, my name's Ian. I'm the Director of Science, Maths and Engineering here at the Sixth Form College. So yeah, obviously the subjects we're going to go through tonight are on the screen right down there. We're going to start with maths and further maths in a second. Just to say a few things to sort of an overview of the whole department. As you've probably or hopefully seen in the past, we, as a faculty, we're doing exceptionally well year on year. Results wise, I mean, we are year on year for the last 4 or 5 years been getting excellent results, really, really impressive, down to the fantastic team that are here tonight. So really proud of the team. In terms of entry criteria, so because everything is quite similar in that sense, I'm going to say that now just so you guys are aware. So if you would like to study any of the subjects on the screen right now, you do need to make sure that you're aiming for at least a 5.5 average at GCSE. Okay, so if you add up your GCSE scores and get your mean total, it has to be at least 5.5. And then the subjects themselves, you need to get at least a 6 in those subjects. Okay, so just making sure you're aware of that before we continue. The only exception actually to that one is further maths. You actually need to get a grade, GCSE grade 7 in further maths GCSE grade 7 in maths, to do further maths. Okay, cool. I'll kick things off. So I'm going to start off with the maths A level. So Amy, if you wouldn't mind turning the screen. Okay, so maths A level is actually the way I usually describe it is it's basically building on everything you've done so far at GCSE maths. Okay, so lots of things will seem familiar in A level maths. A lot of the algebra stuff you've been doing at GCSE will follow through to A level. A lot of the geometry stuff you've been doing, trigonometry. So there's lots of crossover and follow through, but it does get quite a bit harder, just to say that. But also it's still enjoyable. If you like your maths and you want to take that on to the next step, it's definitely a good A level to have. I can't think of a degree that would not be happy with you having an A level of maths, so it's definitely worth having. In terms of comparing maths with further maths, actually, Amy, would you mind just skipping to further maths? So further maths. So obviously, if you really enjoy maths and you want to, if you're considering maybe doing a degree in mathematics or physics or maybe engineering, you might actually want to consider further maths as well. So to do further maths, you do actually need to be doing A level maths as well. So they are 2 separate A levels. As I said earlier, to do the A level in maths, we do ask for a GCSE maths grade of 6. And then to do further maths, we ask for a GCSE maths grade of 7. And that is because further maths is a little bit trickier, and particularly in the second year. In terms of the topics in both maths and further maths, so like I said, maths is more similar to what you're doing now at GCSE. It'll seem a lot more familiar, a lot more crossover. Like I said, it's still a big jump up. Both are still difficult. But when you consider further maths, the maths you do on this course is a lot different to what you've seen so far. So there'll be a lot of topics that actually will seem unfamiliar. So there are some topics listed on the page right now. So things like matrices, complex numbers, hyperbolic functions. These are probably things that you maybe, I doubt have heard of actually. All really interesting, all fascinating, and actually all have real practical applications, but certainly all things you haven't seen before. So yeah, that's the summary of maths and further maths. Obviously, when we get to the Q&A in a little bit, if there's anything I've missed or any questions you have, obviously you can put it in the box later, and I'll happily answer those questions. But that's the summary of maths and further maths. I'm going to now hand over to Kathy, who's going to talk a little bit about biology. Making sure the microphone's on. Is your mic on, Kathy? There we go. Good old microphone.
Good evening. So where do I start with biology? There's such a vast range of subjects. Taking you from GCSE, of course, you will have had tasters of a very different parts of the biology, which we certainly take further. But in addition, there are new topics that you will not have studied before. And these are very exciting studies. For instance, one of them is evolutionary development. This involves, for instance, you could have insects with, instead of antennae, legs in the same places. So it's about the control of genes on other genes. It's a fascinating subject. So if ever there was a time to study biology, it is now. We're in this middle of this pandemic. A small, tiny, would we call it a living thing, virus has caused devastation. And we need to have more biologists. We need to have people working in biochemistry. We need them in pathology. We need them in immunology. But if these subjects are not your particular forte, there are also other subjects which you can do, in, for instance, ecology and zoology. Now, a lot of people take biology thinking about medical subjects. So you could be doing something like, it's a fantastic subject to go forward to be a nurse, to obviously needed to be a medic in some sort of way. So there are a vast range of different work areas that you can do after taking A-level biology. And there are a vast array of different biologically related subjects at university. And I'd like to hand you over to James. Thank you.
Okay, thank you, Catherine. My name's James Moore. I'm the A-level chemistry teacher. I've been teaching A-level chemistry for 15 years. I also mark exam papers for OCR, which is the exam board that we use. So I know what is required to get you through the exam with a good grade. So if you're looking to do medicine, dentistry, veterinary science, biochemistry at university, biology, then you're looking to do A-level chemistry. So we've had some very, very good results over the last few years with AS chemistry and with A-levels. Students have gone on to excellent universities and on to excellent courses. We've got excellent facilities at the college. So although the college is nearly 10 years old, we've still got virtually brand new equipment. All the glassware is excellent. You'll get to use glassware that you've never used before, like Liebig condensers and separating funnels, and you'll learn all about how to use those properly and correctly. You'll be supported throughout A-level chemistry by me. So I run a catch-up session every Wednesday, and I'm always available by email. All class resources are put on Teams, so if you're ill or if you're not in for whatever reason, you can access what you've missed. So come and do A-level chemistry if you want to progress onto an excellent university course. It's accepted in every university for pretty much every course, depending on what you want to do. So it's a very, very versatile subject. So that's A-level chemistry. Over to Tom.
Hello, everyone. As James said, my name is Tom Harrison. I teach the A-level physics at the college. I also teach A-level maths as well. So if you choose to do A-level physics, I do strongly recommend that you do A-level maths as well. So what is physics? I think the most concise way of describing what physics is probably to say it's modeling, usually mathematically, how everything in the universe works, pretty much, from how things move, electricity, nuclear power, astrophysics, you name it, physics pretty much covers it. A-level physics is a really good subject to choose to study at A-level, chiefly because it develops your problem-solving skills and basically makes you very employable. It's a difficult subject, I won't lie to you, but the good news is because it's difficult, it means students who get a good qualification in A-level physics are very highly sought after. You may or may not be aware there's currently a national shortage of physicists and engineers, which is what physics can often lead to. So it really is a difficult but very, very worthwhile subject to study. It will open a lot of doors for you. I think it's important to say physics is not all about maths at A level, okay? A lot of people have this misconception that because they're good at maths, because they can rearrange equations, then they should do A level physics and they'll be fine. There is a lot of maths in it. Obviously, as I say, it's about modeling things mathematically. However, on average, about 50% of the marks in a physics exam come from doing mathematical calculations, and the other 50% come from written explanations, okay? So you do have to be able to actually express yourself in writing as well, okay? So I would say English language is also something that you need to be competent at. Yeah, but you know, as I say, it's an excellent A level. It's difficult, but as long as you're willing to work really hard, okay, it's a very rewarding and worthwhile subject to do. Okay, I'll hand over now to Priya. Thank you.
Thank you, Tom. Good evening, everybody. My name is Priya Suresh. I teach both mathematics and computer science at East Coast College. It's good to see you all online. And with regards to A-level computer science, it's a fairly new course that we are running. So our first cohort are currently doing their AS year. It's an exciting new course. There's never been a better time to learn computer science. Think about what we are doing now. Technology is bringing us together to do this meeting, and there are so many jobs and so many people working in the background to enable this. This is perhaps a subject which will never grow old. There'll be constant developments, and you'll be learning new skills, new technology every single day. In terms of what we do in college, you'll be learning about how processors work. So although you have probably used a number of devices, this subject, A-level computer science, teaches you how actually the computers work. And they'll teach you about algorithms, about data structures, about programming. We learn a number of programming languages, and 20% of your final marks is based on an extensive software project. Okay, so it's all very exciting, but it's not all about learning the theory and doing the code. For example, we were involved in a whole day of artificial intelligence and robotics event online, unfortunately due to COVID, a few weeks back. And this morning we had a talk about cybersecurity from different professionals across the country. So you get to meet a lot of people, you develop contacts, and that leads to, Amy, can I have the next slide, please? Thank you. So what can you do after your course in computer science? You can obviously do a degree in computer science. University of East Anglia run many strands of the degrees, but it's not just computer science. You could specialize in cybersecurity. The job growth in that particular field is exponential, which means you'll never be out of a job being a cybersecurity professional. You can become a network engineer or a database manager. There's so many different ways in which you can get into this field. Okay, so come join us, and I hope you will have a great time at computer science. Any questions, please, do ask at the end of the session. Thank you. Handing over to Chris.
Hello, so my name is Christian. I'm an engineering lecturer at the Lowestoft campus. And so science and engineering, you sort of think, what is this? So this is a amalgamation of two courses, all right, running on two different sites. So it really is the best of both worlds. Okay, so you get the opportunity to investigate engineering, and you can investigate that in a modern industry-specific workshop and environment, and also you can study A-levels at the same time. So it's a new course. All right, so again, this is the first year that we've done it. It's really an enjoyable course to be on and to teach. It's a really fun environment because you're able to put all these different subjects together. As you can see from the slide, we look at sort of engineering maintenance. There's some engineering maths, some science. We're doing electrical and electronics, health and safety, and we're also going to add computer-aided design to it. So it really is a good course, and the progression at the end of it, I mean, the class that we've got at the moment, half want to go into higher education, half want to go into apprenticeship. So those opportunities are there. So if you want to go into HE, some people want to do HNC, HND, and degree level. That's brilliant because you've got the practical application as well as your A levels. And if you want to get an apprenticeship, you're the ones that they're going to pick because you've done all the, you've got a really good engineering qualification and you've got your A levels as well. So it's a really good course. And I'll hand over to Amy.
That's brilliant, thank you. Right, so you've heard from all our tutors now. You've been given a brief overview of all of our courses. So now it's time for your questions. So as I said, Q&A box on your screen. Type any questions you've got in there and we will ask them all live for you now. We've had a couple that were submitted prior to the session that people asked in advance. So we'll start off with those to give everybody else some time to type their questions in. So first question, Christian, for you. You mentioned it was a question about obviously our science and engineering diploma. Someone wants to know how much time is spent in the workshop and how much time is spent sort of in the classroom doing the science side of things.
Okay, yeah, so the units that we're doing, there is, I would say it's probably around 40% in the workshop, 60% in the classroom, but there's a lot of drawing as well. So obviously you're doing practical things, but also in a classroom. So if you think about computer aided design, like CAD drawing, you're still in a workshop, but you're on the computers. So it's probably about 40, 60, or maybe half. But it is a practical course. Does that help?
Yeah, that's great. Thank you, Christian. A question here about physics. Do you cover astronomy in our physics A level?
Yeah, so this is always one of the most popular questions that we get. I'm sorry to say, actually, that there's not a lot of astronomy and space in A-level physics. However, there is a unit on astrophysics. Okay, but this is looking at the universe, how the universe is expanding, what is the evolution of the universe, how did it possibly begin, all those sort of things. There's a bit on star formation, stellar evolution, things like that. But this is only one unit out of 6 in year 13. Okay, so if you're thinking, and as I say, I get this question a lot, I'll make this very clear right now. If you're thinking, I'm going to do physics because I love space, yeah, then that is not a good reason to choose A-level physics. Okay, the good reasons to choose to do A-level physics are, pretty much all the things that I mentioned earlier. It's a subject in which you develop really strong problem-solving skills. So, i.e., the ability to model any situation, pretty much with an equation or using mathematics to solve the problem. So yeah, it's more of an analytical problem-solving subject, which explains a lot of things about how the universe works, with a slight emphasis on space and astrophysics, but that is not by no means the majority of the course content.
Okay, great. Thank you for that, Tom. A general question here, Ian, I don't know if you can answer this one. Do students get an AS qualification after 1 year?
Good question, actually. So as you probably, as some of you may know already, the way sort of the world is heading now in terms of sixth forms is A levels are sort of the A2, the full A2 program, 2-year program is now the main program, and unfortunately the ASs, which we used to offer on the old specification, have obviously over the last couple of years rolled out. So unfortunately, we don't offer them across the board to all students. We can still run them for certain students who want to do them for a certain reason. So it's not like if you ask, you can do an AS, but we don't sort of enter all students into an AS anymore. And it's probably the same for most sixth forms now.
Okay, thank you, Ian. A question here around computer science for Priya. What languages are covered in computer science?
Okay, we teach Python, C++, as the 2 standard languages, but For your software project, which is 20% of your overall marks, you can choose pretty much any language that you want. You will be provided help with it, but most of it will be self-taught. So the basic ones, a object-oriented language and a procedural language will be taught to you. You'll also be taught HTML, JavaScript, and PHP, SQL. So those are sort of standard things that people need to know, you'll be taught. But if you want to say develop your own game, then that's got to be self-taught. You'll be given all the materials, but the work has to come from you. The learning part has to come from you. And people do a variety of programming languages, but the basic ones are these: Python, C++, HTML, JavaScript, PHP, and SQL. Hope that answers your question.
Great, thank you, Priya. I'm sure it does. A question here, possibly Ian or Christian. I would like to pursue a career in architecture. Would science and engineering be worthwhile to pursue?
Good question. What do you reckon, Christian? Do you want to go or shall I go?
I don't know, you could go if you've got an answer.
So architecture, I wouldn't say it would be something that you wouldn't want to do. I wouldn't necessarily say it's the first choice either. So I don't think it would be any harm doing it. I think when I think of architecture, I do think of sort of having an art-based subject as well as a sort of having maths as well. Those are my two key go-tos are art, maths. Possibly physics, but I'm not sure if Tom would agree. But science engineering, listen, if it's a practical subject and you're designing and making, I can't see that being a problem. I think that's actually, the more I think about it, actually, the more I think that's probably a good idea.
In terms of the design, that would be good. You get a feel for engineering practices.
Yeah.
So again, it wouldn't be a first choice, but it wouldn't be a bad choice.
Yeah. So I think it definitely would complement. So I think in summary, I think the answer is yes, it would work well. Okay,
great. Yeah, and if that person did want to find out any more about the kind of art and design and graphic courses we do, we have already run a session on that earlier this evening, which we recorded, and we'll make that available on our social media and website. So if you wanted to have a quick flick through there and see what kind of things you do in those courses as well, if architecture is something you're interested in, then that might be a good idea as well. And then you can kind of pair it with the stuff that you picked up from tonight's session as well. Okay, next question. How many pupils on average are in chemistry, physics and biology classes? Who can help with this one?
I guess I could probably give an overview, but you guys can fill in. I think on average, quote me if I'm wrong, guys, you can chip in here, but I think on average we have between sort of, I think anywhere as low as maybe sort of the low teens, all the way up until sort of mid-20s. That's the usual ballpark figure for the sciences. I can see Tom nodding, so I've got that about right. So yeah, it can range. I think in the first year we tend to have more, and then in the second year a little bit less. But it's usually so. But I think on average it's going to be around sort of 15, 20.
Great. And while we've got you, Ian, hopefully you can answer this one. On the application form, do you need to put in the predicted grades that your teacher is going to give you? I think obviously quite a few people probably don't know what their grades are going to be yet. What should they do around that?
Yeah, I think if you have a school report, I would put in the grades that are on that. In reality, when I have an interview with a student, I actually end up asking the student and saying, look, do these grades seem suited to what you think you're going to get? Really what I want to know is what do you think you are going to get this summer? What's the best guess? But if you've got a school report, I would definitely put those grades down. And then as part of the interview process, as part of the conversation, you could maybe discuss those grades and say, you know what, that grade that I got predicted, I think I can do better than that, or this grade maybe is a bit too high. So I would put down school report grades, and then you can have a bit of a discussion around it in the interview.
Brilliant, thank you. A question here on biology. What practical sessions are done in biology? I don't know if you can give a few kind of examples of some of the things you do in class.
Yes, certainly. We do a lot of practicals actually. Altogether, the minimum you do is 12, but that's the minimum. So for some topics lend themselves to a lot of practicals. For instance, at the moment we're doing enzymes, so you'll be doing rate of reactions, looking at different factors. We do planning of experiments. planning investigations. We do dissections, something like the heart and the lungs, and we use the microscope a lot. We have a look, we've just been doing the kidney, so we've been looking at the kidney cells. But there are many different ones, looking at the food, the types of food, looking at, in particular, perhaps the concentration of glucose in different solutions. And we do work on water potentials. We do work on photosynthesis. So there's a lot of practicals and a lot of wide-ranging different practicals that we do. And we try to do as many as we can for the time. So you have to build up skills. And just like in chemistry and physics, it's a very similar process. So that there are things that we call PAGs, which are these practical skills. And so altogether there are 12 groups that we have to work through. And there are different skills that you'll learn in each practical. Now these are very important, not only because they require analysis of the data, but also they'll be required for your exam. So a lot of the questions that you are asked in the final exam are on the practicals and analysing the data. There's quite a lot of maths, I have to say, in biology, a lot of statistical maths. We do need the chemistry as well, so the chemistry is a very useful subject to go with biology if you're thinking about that. Thank you.
Great, thank you for that. Our next question is actually a chemistry one. How often do you get to study in the lab?
Well, I mean, my lab doubles as a classroom, so every lesson that we have will be in the lab. I suspect the question you probably want to ask is how many practicals do we do, or how often do we do practicals? It's probably the same as Catherine. There are certain topics in chemistry that relate quite well to doing practical work. I do like to start off with at least 2 practicals early on, so that we can kind of get going in terms of practical skills and so on. But then when we get to the more theoretical side in the first year, there isn't really many opportunities for a practical. But once we get into the second year, then every week we will do a practical. I hope that answers the question.
Great, yeah, thank you, James. Ian, this might be another one for you to jump in on. If I want to take 2 sciences, am I able to take humanities alongside it?
Almost always, yes. You can certainly do that. Obviously, we always want to make sure that whatever subjects you're doing, they kind of match up with where you want to go. So if you are doing 2 sciences and humanities, the next question would be from us would be why? What is it you want to do next? But 99% of the time the answer is yes. The only reason it would be a no is if there was a timetabling issue, but very rarely will that happen. So yes, basically.
Great, thank you. A question about the science and engineering diploma. Oh, okay, so somebody's asked, is the science and engineering diploma the same course as the EAL level 3 science and engineering course detailed in the prospectus? I think that's very much a yes. I don't know if anyone wants to expand on that.
Yeah, it's the same course. I mean, what we're going to do is, I think we're going to add an extra unit in, which will basically give you the extended diploma. So you'll get 72 UCAS points at the end of the 2 years for the EAL. So it's the same course, but slightly more bespoke for you guys.
Great, Christian. And while we've got you, there's another question here. Is there a final practical exam for engineering?
So how it works is each unit has got some practical elements to it. So we have health and safety, which we're doing first. That's called an online exam. The rest have practical assessments and theoretical assessments. So we have like an exam. So each unit has its own exams and practical assessments. So they run all through the year. So, but a lot of them are in-house as well. So again, each unit is slightly different, but you don't have one exam at the end.
Great. Yeah, great. Thank you. James, do we do organic chemistry?
Well, the answer to that question is yes, very, very much so. We do 2 large modules of organic chemistry. So we do one module in the first year, and that's coupled with some spectroscopy stuff that we need to do. So we look at alkanes, alcohols, alkenes, reactions of those, mechanisms, halogenoalkanes, some of these molecules you might not be too familiar with. In the second year, we look at benzene, phenol, and reactions of those. We look at aldehydes, carboxylic acids, amino acids. So yes, we do, and it's quite a large part of the course.
Great, thank you. Right, a couple more questions. Would it be recommended to do maths and or physics if I wanted to do the science and engineering course?
I'll jump in there. I think the answer is yes. As I'm sure Christian and Tom would agree, maths, physics and engineering all go very well, very hand in hand. Particularly, if you want to do an engineering degree, for example, go into engineering in some way, shape or form, maths and physics are your go-tos for sure. In fact, I think a lot of an engineering degree would end up being a lot of maths and also physics. So yes, those three definitely go well together. Don't know if you want to add anything, Christian or Tom?
No, that's fine. Yeah, they're perfect.
Great. A bit of a sort of a general question around the sciences here. What exams are there for the sciences at the end of each course? I don't know if that's different for all of them or whether there's one answer that suits all.
Yeah, there is probably an answer that suits all, but again, I'll check in with Catherine, James and Tom in a second and Priya. So because almost all the subjects here are A-levels and 2-year linear A-levels, so we end up having all the exams now at the end of 2 years. And it's going to probably be somewhere between either 2, 3 or 4 exam papers. I think usually 3 exam papers at the end of 2 years. So for maths, it's 3 exam papers. I'm guessing for chemistry, biology and physics and computer science, it's similar, unless you guys have any. Priya, what's yours?
I've got 2 exam papers and 1 practicals, 1 software project.
Yes, good point.
Okay, lovely, thank you. Actually, another question for you, Priya. Can computer science be done alongside digital games production?
Of course. We have students doing that this year. So you can combine BTechs with computer science. You can, so digital games production would be, it's one block, isn't it? So I don't think Richard is running an extended. So it could be considered as one of your A-level. You could then do your computer science, your games design, and you'll need to choose some other subject to make up your 3 A-levels. Yeah,
okay, lovely, thank you. I think we're done all the questions. We have had one more in, but I think we've already covered this. We've been asked about practicals in biology, but I'm sure Catherine already, I think we've covered that one, and I think she said there were a minimum of 12 that you get to do. Correct me if I'm wrong there, Catherine, but I think we've already said that one, haven't we?
Yes, I mean, when we say the minimum, that is really the bare minimum. We do far more than that. So I like to do a lot of practicals. I think it's very good for the learning process. And I just think it's gives you lots of opportunities to go deeper into that particular topic.
Great, that's brilliant. Okay, lovely. So that brings us to the end of our questions. So thank you very much to everybody for joining us this evening. As you'll see on screen now, our website is listed there. You can apply now to join us in September 2021, so next September. Our website has got all information about each of our courses, and also the application form on there as well. So you can go on there now, you can fill it in, you can pop down your preferred choices, you can add a few extras in if you're not quite sure, and get that sent off to us as soon as you can to secure your place for next September. If you've got any questions that you think of after this event that you'd still like to ask, the email on screen here to help at eastcoast.ac.uk. If you send anything through to there, then we will funnel it out to the teachers that are on the Zoom this evening and make sure that we can get some answers back to you. We've also got our social media accounts, so you can follow Lowestoft Sixth Form on Twitter, Facebook and Instagram, so you can get a feel for college life and see some of the things that our students are up to at the moment. And just one final thing to let you know about as well is that we do have a virtual tour of our college. So again, if you visit our website and click on our virtual tours tab, this will take you through to a kind of 3D tour of our building. So you can start right at the entrance work your way through the floors, take a look in some of our classrooms, some of the spaces where you'll kind of study and relax with friends, and get a real good feel for the college. So it's a really great tool to use at the moment. Unfortunately, obviously, we can't invite you in just at the moment, but we really do hope we'll be able to do that in the new year. But for now, if you haven't yet been to see us and you'd like to have a look around, then please take a look at that tool. It really is a good way to look at our lovely college. So thanks again for joining us this evening, and we hope to meet you all soon. Thanks. Bye-bye.